What's going on, guys? Mr. C here. One thing you'll notice is I have two different titles. So we have a lesson 11.3 for Algebra 2 and a lesson 13.4 for Geometry. So depending on what class you're in will be where the lesson is located, but they are basically the same lesson again, which is why I'm just doing the one video for both. It's funny, even some of the section examples in the book are the exact same examples. So yeah, just going to go ahead and do it in one video. So going to be talking about compound probability. So like the probability of two events happening, or the probability of one event or another event happening. So what we're going to be going over today. So let's go ahead and take a look at a couple formulas. So here we have the probability of A and B, and then the probability of A or B. So those are two different things. The probability of an event A and an event B means two things need to happen in order for that to be a positive outcome. And the probability of A or B means either A or B, only one of these need to happen for it to be a positive outcome. So if we're trying to find probability of event A and B, this is just multiplying the two probabilities together. We'll give you the probability when we're doing and. If we're doing or, it's going to be adding the two together and then subtracting the probability of A and B. So probability of A plus the probability of B, subtracting the probability of A and B. The reason why we subtract here is because if you add these together, there's some duplicates, and I'll go over an example later and explain that with some visual aid. But we subtract because when you do it this way, you accidentally count some duplicates, okay? Some duplicate outcomes. So those are the two formulas we're going to be using today. Let's talk about independent versus dependent events as well. So here's the best way. They give us two pretty good examples to classify independent versus dependent events. So imagine we're rolling a number cube, then doing a spinner. Okay, like a spinner, usually you see that, like the Game of Life has a spinner. A lot of board games have spinners, something like that. Wheel of Fortune, that's a spinner. So if you're rolling a number cube, then spinning a spinner, these are independent events. The outcome of the number cube, if you're confused, that's just a die. The outcome of a number cube has no effect on the spin of a spinner. However, in the second example, pick one flashcard, then another from a stack of 30 flashcards. This would be an example of dependent events, okay? Reason being because if I've already picked one flashcard, when I go to pick the second card, there's fewer cards. Okay, so the first time I pick a card, there's a total of 30, but the second time I pick a card, there's a total of 29. This is an example of a dependent event because the first event had a effect on the outcome of the second event. Okay, it changed the total number of cards. So that's what we mean when we talk about independent versus dependent events. Right. A couple more things I want to talk about. Again, this is going to be a short lesson. Let's talk about mutually exclusive events. So when things are mutually exclusive, that means they can't happen at the same time. Okay, like being a boy or being a girl, those are two mutually exclusive events. What else is being blue and being red? You can't be a color that's blue, you can't be a color that's red. For probabilities sake, let's talk about rolling a 2 and a 3. If you're rolling a die, okay, what's the probability of rolling a 2 and a 3 on one single roll? You can't roll a 2 and roll a 3. That doesn't even make sense. You can't roll those at the same time. Those are mutually exclusive. Now, rolling an even and a multiple of 3, that's not mutually exclusive because 6 is both even and also a multiple of 3. Okay, so that would be not mutually exclusive. And you can see here the probability of a mutually exclusive event is always going to be 0. So what's the probability of rolling a 2 and a 3? It's 0. You can't do it. Okay. All right. Let's do just one example here, and then we will call it, let's say we have this little, I don't know, a dish of, just looks like a plate with shapes on it, with all of different colors. So directions say to choose one shape at random. Find the probability that the shape is round or that the shape is green. Right? So this is an OR problem. So what's the probability that one is round or green? So we could just add them. I mean, looking at these, it's not too hard. You can just kind of add, okay, how many round ones do I have? I have 1, 2, 3, 4, 5. And how many green ones do I have? Excuse me. How many green ones? I have 1, 2, 3. So a total of 5 plus 3 is 8. And then how many total shapes do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total is 9. However, 8 out of 9 is not technically correct. So what's the error that I made when counting these? I said, okay, there's 1, 2, 3, 4 round ones, and then there's 1, 2, 3 green ones. The error is I counted the green ones, the round green ones twice, right? I said 1, 2, 3, hold on, sorry, one more second. I said 1, 2, 3, 4 rounds, 1, 2, 3 greens for a total of 8. But when you do it that way, you accidentally count the round green ones twice. So technically, it would be 1, 2, 3, 4, 5, 6 out of 9, which should be our probability. So if you think about it, going back to our formula, that's where this portion of the formula comes into play, where you subtract your duplicates. Okay, and I have 2 duplicates, right? I have 2 that are both green and round. So this 8 here, 8 out of 9, we technically needed to subtract then 2 out of 9 because there's 2 duplicates, which gives us a 6 out of 9, 6 out of 9, or a 2/3 should be my probability. Okay, so you can do it that way. I mean, this example is easy enough to just count them, but if you have larger totals, you're going to want to use that formula where you add them all together, then subtract your duplicates to get your probability. Okay. All right. Let's actually just do one more, just because we didn't do an and. I want to make sure that I answer any questions on the ands. So let's just do one more. Let's look at this one. Okay. Just to make sure you guys understand what to do with the ands. It says, suppose A and B are independent events. What is the probability of A and B if the probability of A is 50% and the probability of B is 25%? Okay. Formula for and said to multiply these two things. So as a percent, what are those numbers though? Technically, if I'm trying to find the probability of A and B, as numbers, 50% is 0.5, 25% is 0.25. Okay. So what is half of 0.25? What is this going to be? 0.125 or 12.5%. Basically, it's saying take half of 25%. Half of 25% is 0.125 or 12.5%. If we're multiplying those. So remember, and means to multiply those two. That is it for today. We are almost done. Still not sure what I want to do for our last week, but I'll keep you guys posted. Yeah, I'm sad that I can't spend our last week together. Gonna miss you guys over the summer. Can't wait to see you guys next year. And yeah, that's it. I'll talk to you guys later. Peace.